Alright, so we've been doing some differential equations already, but every differential equation we've done has had x in the equation. Things like here, dy dx equals 2x plus 1 on. You can see there's x in the equation, there's x in the equation, x is on the bottom of our differential equation, whereas now we're going to do a differential equation with y in the equation. So dy dx equals y. There's a problem here because we can't just anti-differentiate it because in that case it would be y is equal to and then something in terms of y. So we need to do something first to sort of fix that problem. All right, so step one is going to be to invert our equation. So we can say that for this first one here, which is dy dx equals y, we can invert left and right and say that the derivative of x with respect to y is equal to 1 on y. So nothing overly tricky there. So now we can just anti-differentiate that. So we can say that x is equal to the integral of 1 on y. So x is going to be equal to log base e y plus c. We can write log base e y plus c or just write ln y. Either one would be fine. I'll just write that there. I've just been a little bit lazy there. I should just write if I'm integrating 1 on y with respect to y. Okay, now, but this isn't a solution to dy dx. This is a solution to dx dy. So in order to make it a solution to dy dx, we'd really just need to rearrange this to make y the subject. So it's going to be x minus c is equal to log base e y. And then we can write this in exponential form. So we can say that e to the x minus c equals y. And then that e to the x minus c, we can say that that's e to the x times e to the negative c. And then that e to the negative c, well, the c is like an arbitrary constant, and e is a number, which is 2 point something something. So it's 2 times an arbitrary constant. So we can kind of collapse this. We can say let e to the negative c equal a, let's say. And now we have y equals a times e to the x. All right, so that was the first one here. The second one here, it's y dash x equals tan y. Now I might just write that as in the familiar notation, dy dx equals tan y. And again, we've got the same problem. Our equation has y in it, so we've got to do our little inversion trick here. So we can say dx dy equals tan y, and then we can say that x will be equal to the integral of tan y with respect to y. So to integrate that tan y, we can just write it as cos y over sine y with respect to y. And then you might need to think back a little bit, but cos y and sine y, we've got the integrand present, or the derivative present. So we can use, sorry, we've got the derivative present here. So we can use the derivative here by letting u equal sine y. And then that means that the derivative of u with respect to y would be cos y. And then we can rearrange that to say that du on cos y equals dy. And then, so I've put this in red because it's just kind of a little bit of, I won't say extra working, but I can now use that du on cos y in place of the dy here. So when I do that, going back to the regular color, I'll have cos y over, and I let u equal sine y, so still sine y there, times, and then instead of dy, I'm going to have du cos y. And those cos y's are going to cancel out. And now I'll have the integral of du, which can really be written as 1 on u with respect to u. And that's going to be log base e u. No, I've already integrated it, so now I'm pretty close here. I just need to replace the u with whatever I started with, which was sine y. So log base e sine y, that's equal to x. All right, so x equals log base e sine y. I really just need to rearrange that now to get it in terms of y. Before I do, it's a bit naughty. Forgot the plus c there. So now we have x minus c equals log base e sine y. And we can then rewrite this as e to the x minus c. And you know what's going to happen with that because it happened over here. And we've got sine y there. And then y is going to be equal to inverse sine e to the x minus c. Something like that. That's sine to the negative 1 e to the x minus c. And then that e to the x minus c, in the same way that it became a to the ex, it can be a to the ex again here. All right, so a little bit of working there, but there's nothing too complicated. I really should just write my steps in. Step 1 was to invert it, and then to integrate it. And then once you've integrated it, which we've finished here, so step 1, invert. Step 2, integrate. And you might need to use some method here like we did there. But after step 2, integrate, is step 3, make y the subject. Okay, it's pretty much the same every time.